now we're going to think about how equilibriums respond to stress. And I always feel like I need to pause, and this is, MIT students, you guys are some of the smartest, most talented scientists in the world. You really, I don't know if you fully appreciate how smart you all are. But this concept is tough for MIT students. So Le Chatelier's principle says that a system in equilibrium that is subjected to a stress tends to react in such a way to minimize that stress. I have advisees coming to my office saying, I'm double majoring in this and that, and I'm taking 5 classes, and I have the Europe, and I have this lab exercise. I don't know what's going on, so I've been thinking a lot about it, and I think I should add a 3rd major. Le Chatelier would be very unhappy with that. Le Chatelier would say that the appropriate response is to drop one of the majors, to minimize the stress. So in doing these problems, what I want you to encourage you to do is think the opposite of what you would do. Minimize the stress. If you think about that, you'll be all set. All right, so Le Chatelier's principle actually is very useful. If you think about minimizing the stress, you will be able to predict the direction that the reaction will shift. So the reaction is going to shift in a way to minimize the stress, so you can predict it. If you're thinking along these lines, you say, oh, that system was stressed, and then you can think about how that reaction or that system is going to respond. So let's give some examples. So we have a system in equilibrium. We started out, we had our nitrogen and our hydrogen, and we had no product. We reacted the hydrogen and the nitrogen. They're forming products, and eventually they reach equilibrium. Delta G equals 0. There's still the reaction going on, but there's no net change. All right, now the system is going to be stressed. So we're going to add more of a reactant. How will the system react to minimize that stress? What is it going to do? It now has too much of one of the reactants. You'll form more products. And that's going to use up some of your other reactant, which will go down, and you're going to form more product until equilibrium is reached again. And one thing that I'll mention, that the ratio has to be the same. The equilibrium constant is a constant given the same temperature, but you're not necessarily always going to have the same concentrations, but you should have the same ratios, the same value of K. All right. So what about if you add more product? What's going to happen? What direction will the reaction shift? Right. It's going to shift toward the reactants, so you're going to make more of each of the 2 reactants until, again, you find your equilibrium again. And then the reaction's still going, but there's no net change anymore.